Good morning, dear student. Today I am going to take your class on organic chemistry. The topic will be stereochemistry and optical activity. So the paper code is CHE-HC 2016. So before going to the stereochemistry, we have to understand what isomer is all about. Isomers are the compound which having the same molecular formula but different structures. So these isomers can further be divided into the three types. One is called constitutional isomer, geometrical isomers and optical isomers. So these constitutional isomers again are we can see these constitutional isomers means they have the same molecular formula but they have the different connectivity. We can see here the Cl is connected at the bridge and here Cl is connected in between the two carbons. So these are the constitutional isomers. Now what is stereoisomers? Stereoisomers are again out of two types. One is called enantiomers and diastereomers. So we will go into the details of these stereoisomers. So what are this stereochemistry and what are the stereoisomers? Stereoisomers means the arrangement of atoms in space. They will have the same molecular formula but the arrangement of atom will be different in space. Say let us consider this molecule, say methane molecule. So if I marked one H1, this is carbon and these four all are hydrogens. So if I consider this all are hydrogen H1, H2, H3, H4, we can see here from this model this one hydrogen is going toward itself and one hydrogen is on the plane and two hydrogen is on the back side. So we can see these three are on the three different planes. So they will be called as stereoisomers. So students are afraid of the stereochemistry because we have to introduce here few basic terms. If you know the few basic terms of stereochemistry, then it will be very easy to understand. So now let us see what are the stereomers. So as I have mentioned already, these isomers have the same connectivity but differential spatial arrangement of atom or group giving rise to a different properties. So these are the enantiomers and diastereomers which I will be discussing in my next slide. Now what is enantiomers? Enantiomers are the compound which having the mirror image but non-superimposable. So if I consider this hand and this hand, these two hands are of my mirror image. But if I try to come and impose, it is non-superimposable. You can see these two thumb finger are in the opposite direction. That means these two hands are chirals and they are the enantiomers. So we can see from this structure the hydrogen is on this left side and another hydrogen is on the right hand side. This is the mirror image and also this is non-superimposables. So this is one of the example of the enantiomers. So now this enantiomers we can be explained on this figure. So you can see these are the mirror image but we cannot superimpose. You can see the B is this side and A is this side. If I try to say, you can imagine that I am moving this molecule to here. Can I put it here? No, because this side is B and this side is A. So that means this molecule is an mirror image but non-superimposable. So now you can see here that stereoisomers, we can see here stereoisomers are of two types, that is diastereomers and enantiomers. What is diastereomers? Diastereomers are non-mirror image whereas enantiomers are the mirror image. Of course they have the different spatial arrangement. So we can come to the few basic definition of the stereoisomers. So this we have already explained. These enantiomers are the compound which having the mirror image non-superimposable and diastereomers are the compound which are not mirror image. And what is the difference between these enantiomers and diastereomers? Enantiomer will have the same physical properties like melting point, boiling point, chemical reactivity. So the only difference we can differentiate between the enantiomer is their optical activity, which I will discuss in my next slide. Another few definition is asymmetric carbon. What is mean by asymmetric carbon? which means that the carbon which have 4 different atom attached to the molecules. So, you can see this is a carbon, and you can see these atoms are all of 4 different colors. You can consider that this black ball is known as the chiral carbons, and this chiral carbon is also known as asymmetric centers. Now, let us come to the optical activity. What is meant by optical activity? So, we can see here optical activity, the term itself is related to optics. What do you mean by optics? Optics means light, and activity means any kind of compound which is affected by the light. That means, if the light fall on this compound, it will show some kind of activity. So, and that kind of compound activity will be known as optically active compound. So, you can see an optically active compound is one which rotate the plane polarized light. Now, again come the what is this plane polarized light? Now, let us see the plane polarized light. Plane polarized, the name itself means plane, means it should be in one plane. So, what we have to do? We have to take a light, and we know that the light travel in all direction. So, we have to put one polarimeter filter, and we can see that light is in one direction. You can see the yellow color here, this is in one direction. What we have to do? We have to pass this plane polarized light through the sample where the optically active compound is there. Then we can see this plane polarized light can rotate. Either it can rotate clockwise or it can rotate anti-clockwise. So, basic on this property, this optically active compound can also be further divided into the 2 types. If the plane polarized light rotate clockwise, it will be called dextrorotatory, and if it is rotate anti-clockwise, it is known as levorotatory. Now, the question comes, what kind of compound will show this optically active compound? Let us consider the benzene. Will be it an optically active compound? The answer will be no, because to be an optically active compound, the compound must have a chiral center. So, as I have discussed, what do we mean by chiral? Chiral means there should be one atom where all other atoms should be different. Say for carbon, we know that carbon has a 4 valency. We can see here the 4 atoms are of different. That means it has a chiral centers. So, that means the compound which have a chiral center will show optically active compound, and this phenomenon was first observed by the Jean-Baptiste Biot. We can see in the early 90s, he concluded that the change in direction of plane polarized light when passes through a certain substance. What do you want to say? That it's certain substance only can rotate the plane polarized light, not all, like say benzene or say methane, they will not rotate the plane polarized light. And this was further studied by the Louis Pasteur, and he shows that he did enormous experiment on that, and he shows that the tartaric acid is, which is tartaric acid, we all know this, it is found in wine, right? Tartaric acid is found in wine, and we can see that this tartaric acid can rotate the plane polarized light either clockwise or anti-clockwise. So, that is the optically active. Now, the thing is how to calculate this, how much light will be rotated. So, we have given this alpha dt, and T is the temperature, and we know this alpha is the observed rotation, how much light will be rotated. T is the temperature, at what temperature the reaction is been doing. D is the D line of the sodium vapor, what is the source of light we have used. Here is 589.6 nanometer, and length of the holder tube. What does mean by length? Suppose I can took this sample into a glass or into a big bucket. So, if I take into the big bucket, the length will be more. So, like this is the length, and we all know the concentration. So, like this we can calculate the specific rotation of the compounds. Now, let us come to the topic that resolution of this enantiomers. Now, we all know this enantiomers means it can rotate the light either clockwise or anti-clockwise. So, if I want to separate these 2 compound, we have to do some resolution. We have to separate this compound by using a mixture of racemic and a pure enantiomers. So, what will happen if I react these 2 compound? I will get a diastereomers, and this diastereomer can be separated by the simple procedure. So, that is how we can separate the enantiomers. Now, what is this racemic? Racemic means if that compound contain 50% of R, that is dextrorotatory or levorotatory, then the light will not rotate in any direction, because if it rotate 50 degree and again it come back to the another 50 degree, that means the light will be in the same position. So, what kind of compound it will show? It will show by the racemic mixture. So, you can see some of the optically active compound which is found in the natures. Now, the question is that why we have to study the asymmetric carbon compound? Why it is so important? Because there is always some importance in our daily life or in some our daily life or in some practical application. The purpose of studying this asymmetric compound is what? Because in early days people doesn't know about this asymmetric compound. What they used to do, they just make a molecule and they used to eat. So, we can see there was an incident in 1950s in the United States. They have prepared one compound called thalidomide, and this thalidomide contain the mixture of both, that is dextrorotatory and levorotatory. What happened? This compound was taken by the many people for, we can see it is taken by the pregnant women, then some cancer, some other diseases. So, what happened? After a few days they have found that after taking these dopamines, the child was abnormal. We can see from the picture the child is not normal. The question is why? Then come to the picture of asymmetry. It was found that this is the thalidomide compound, it contained the mixture of both R and S. What happened? This S isomer is a toxic, right? This can causes your damage to your health, whereas R isomer is a medicine. So, what we understood that though the compound is same, but depend on their rotation or their optical activity, one can be used as a medicine and another can be used as a your toxic compound. So, that is why we have to isolate the isomers, and that is why we have to study the asymmetric compound, because it has a great application. Because if you just synthesize the compound and if you doesn't do this kind of asymmetric compound, pure enantiomeric compound, then it might be your medicine or it might be your toxic compound. So, that is the purpose. We have to study the asymmetric compound and we have to isolate the, we have to see the each properties like for R and for S. So, that is why we have to study this thalidomide compound, and this you can see here, because of this mistake over 20,000 birth defect has been found in children and who were born to women who took the drugs during their pregnancy. That is why separation of enantiomer is highly important. Thank you.